if you look at all of these, all of the discussions we've done, okay, changes in the right hand side coefficient, changes in the left hand side coefficient, changes in the objective function coefficient, adding a constraint or adding a decision variable, all of these things we relate to either the model relaxing or tightening. Okay? However, it only tells us how the model will be affected. It will only tell us if the model will be better if it's relaxing, or if the model will worsen if it's tightening. It doesn't tell us exactly how much will the optimal value increase or decrease. And that is why in every slide here we talk about uh, we're talking about sensitivity analysis in a qualitative sense. We just know in what direction the optimal value will move. Will it move up, or will it move down? Will it move down? What we need to know next is how exactly a change in the model will affect the optimal value and the optimal solution of that said model. And that is where we will be discussing quantitative sensitivity analysis. Okay? And this is where we will be using duality theory. Obviously, you can resolve the problem, or you can solve the problem again. However, in this case, we will be taking advantage of a theory called duality, where we will be able to quantitatively know how changes in the model will affect the optimal value. And let me take this opportunity now to introduce to you the main concept in duality theory, which is called shadow prices. What are shadow prices? By definition, shadow prices are marginal. Shadow price is the marginal value of a particular resource. Technically speaking, the shadow price of a resource is the rate at which z changes for every relaxation of the right-hand side of a constraint. Now, let's take a look at this definition. It is the rate at which z changes for every relaxation of the right-hand side of a constraint. What I'd like to do is to write the definition here. No? So it's the rate at which z changes. Okay, and in this case, we look at the rate at which z changes for every relaxation. And if you remember relaxation, that means it is a change in the right hand side of a constraint for the better. Okay, so the shadow price is the rate at which the z of your linear programming model changes against pitted against a change in the right hand side of your constraint. And if you notice this definition, it should be quite familiar to us. Why? Because we've been discussing this, and we've been actually getting this in our previous lesson. This is actually your change in z over change in, well, in this case, steel. Remember, in our discussion before, we were able to compute the change in z over change in steel to be 25 pesos per unit of steel. And in this case, 25 is the shadow price of steel in the red blue gadget problem. And what does it mean for the shadow price of steel to be 25? It means that the marginal value of steel for ABC company in the red blue gadget problem is 25. What does it mean for it to be the marginal value? It is the value of steel to the ABC company when you add an additional steel. And that essentially means if the shadow price is 25, Z will increase by 25 if your steel increases by 1. Okay? And that is the shadow price.